Hello everyone, welcome to Chaudhary Data World channel. Today I am here with a new video in Pandas tutorial series, into which we will be covering today the topics like encoding in categorical data and handling outliers, which is going to be the third part of the data transformation videos. In two parts, in first part we have covered up this particular topics. In second, we have covered up reshaping of data. In third, we are going to cover encoding categorical data. We'll be knowing what feature engineering of in data, and then handling outliers. So let's get started with the video. Before moving ahead with these three, or you may say whatever we are having today's agenda, let's get first back to the learning roadmap, what we are covering up in this whole series. So we are using this learning roadmap, into which I have covered up data import, data exploration, data cleaning, data selection and indexing. We are on data transformation. Today this is the third video of data transformation, into which basically we will be focusing on encoding categorical data and handling outliers. Now the question comes that why we are even leaving this feature engineering of data. Feature engineering is nothing but if suppose anybody tells you that what the feature of this whole particular data set, then whatever fields into that, whatever columns into that, those only columns are called as feature. Now when you play around with that columns, it is called as feature engineering. So there is nothing much on that to explain. So whatever you have seen into the second part and the first part, those were only called as feature engineering. That means wherever you were dealing with the column of the data set, that is only feature engineering. So the new part over here right now we are having is encoding and then handling outlier. So inside encoding, we are having again two types of encoding. One is one hot encoding and another one is level encoding. So why we are encoding our categorical data? The question is this one right now. So since our whole of the machine learning or whatever going forward, you will be using this whole Pandas into advanced analytics, our analytics doesn't go on any string value. It needs some numerical value. To convert the string value to the numerical value is only called encoding. So it can be of two ways. So suppose we are moving ahead with the first, that is one hot encoding. This is the first type. Now what happens in one hot encoding, if we are taking an example of color, okay, so there we are having three colors, red, green and blue. So what will happen if we will do one hot encoding? So it item is, if an item is red, the red column has 1 and others have 0. So what it happens, that suppose if you are having a column with having values red, green and blue, if you are one hot encoding it, what it will do, it will create separate three columns, one with red, another with green, third one with blue. Now in the first column red, it will be 1 for the red value, and for others whatever columns are there, for others it will be 0. For green, and better you will understand when I will demonstrate it. For green, green will be 1, others will be 0. For blue, blue will be 1, others will be 0. So this is one hot encoding. And level encoding is something in which what we do, we assign the value to each of the different categories. Suppose red, green and blue, again we are having colors. So what we will do, we will assign red to 0, green to 1, blue to 2. So wherever the red will occur into your data set, it will be represented by 0, green will be represented by 1, blue will be represented by 2. In most cases you will be using this level encoding, and some of the cases definitely you will be using one hot encoding as well. So you got the concept, what is one hot encoding and what is level encoding. Let's jump to our demonstration, where we will be seeing now that how we can apply one hot encoding. So for that we are having this particular data set, into which we are having the column as category, and category having small, medium, large, small, medium, any arbitrary value. Now where we are one hot encoding, for that we are using pd.getDummies. This particular one or this particular method is only there for one hot encoding. Into that we are passing the parameter as data frame, and on what column we are using going to one hot encoding. So that column is category column. Since in this whole data set only we are having one column, that is category, but then also we are redefining that column is going to be the category column for which we will be one hot encoding. And then prefix. Now what is prefix? So you can see over here that category large, category medium, category small. So this category, from where it came, we are only having large, medium and small. So this is concatenating this category thing. Okay, so this is your original data frame. Okay, now after one odd encoding, what it happened, it looks like this. So what it is doing now, it suppose this is category large. So what it is doing, it is making one for the category large. If it is having category medium, it is doing this one as the category medium. So what you can see, in medium we are having two values, so it is making two ones, correct? For large we are having only one value, so it is making one for it. And category small we are having two smalls, so it is making two small. From how it is doing, it is using this particular arrangement. If you can see, we are having large in between, small at the top, small at the bottom, which you can see over here, and so on. So hope you got the concept of one hot encoding, how we can one hot encode our data set. After that we are having another type of encoding, that is label encoding, in which what we will do, we will encode our label into our data set. So what happens, let me show you. This is going to be your original data frame. This is only going to be your original data frame. Once you label encode it, what it does, it does only a small thing, that is, it is assigning the value. For a small, the value is 0, for medium the value is 1, for large the value is 2, and so on. How it is doing, it is first mapping the table. It is first mapping it. How it is mapping, we can map it manually. For a small 0, for medium 1, for large 2. Now the question comes that is there any automated way with which we can map this automatically? Yes, we are having that automatical way, but for that we need to use some other library, which I will definitely explain you in upcoming video series or something like that. But if you are using Pandas, you don't having any automatic method for it. You can just map this manually, and after that you will apply onto the data frame. So this is going to be your data frame, on which dot map you will just apply, and the parameter you will provide as label mapping, which you have created as the dictionary. So as soon as you execute it, you just get it, that is label encoded data frame. Now we will be moving to the next concept, that is handling outlier. Now the question comes, what is outlier even? So outlier is nothing but the value into your data set which is odd one out. What you can see over here into this example, we are having 10, 12, 14, 15, 16, 18, 19. Also we are having 100. So what your common sense says, this 100 is going to be definitely lie outside of your whole of the data set, correct? So this is the odd one out. 100 is the value which is not getting you may say similar to other values into this data set. So we need to find those values which is outlier into data set in some of these scenarios, in the practical scenarios. To do that, what we do, we use our quantile function. Now what this quantile function is, I will definitely explain when I will demonstrate you now. After that, we are having multiple steps with which we process and then go and find out our outliers. And once our outliers is getting detected, we are manipulating those outliers. Either we can assign that outlier as NA, or we can assign that outlier as 0. We can assign any value to that if we can find out the outlier from the data set, correct? Why we are doing so? So that our data set should be uniform and it should be more you may say it should be more helpful, or it should be aligned with our data set into the analytical purpose. So let's jump to our demonstration. Here you can see this is going to be a bit you may say technical or mathematical part. So just focus for 5 minutes, you will get to understand that how we are even calculating this outlier. So here you can see we are just defining our data set. Data set is nothing but it is having only one column, that is values. Against that values we are having that values 10, 12, 14, 15, 100, 16, 18, 19. Now how to calculate this outlier? So to calculate outlier, we are calculating Q1. Q1 is what? Q1 is a mathematical term which is called, as you can see over here, that first quadrant. Here you can see where it went. Calculate the median Q1, Q2, or calculate Q1 first quartile. Now here mathematical term says that it is quartile, but your Pandas says it is quantile. Mark this difference. So to find out this Q1, what we do, we use our data frame with its column and then with the method dot quantile, and inside that we are using 0.25. What this 0.25 is even? So this 0.25 is your percentile. If you are aware of percentile, how we calculate our percentile? So whatever our data set is, if you are aware of percentile which we were having into the CBSE, if you are aware of it, so how we were calculating it? We are getting 98 percentile or we are getting 97 percentile. It tells you that wherever you are understanding into whole of the CBSE, definitely whatever you percentage you got, suppose you got 98%, you are on the 99 percentile category. What it tells? That means it is telling you that 99 among 100 student, you are the 99 people are below your percentage whatever you got. That is the layman understanding what you can get. So this 0.25 is the 1/4 percentile what we are asking to Pandas to give as the quantile. Now what this quantile, again you can confuse over here, so just concentrate. We can find out this quantile in only 3 to 4 steps. So first step, what it is, sort the data in ascending order. We will sort the data in ascending order. Calculate the median Q2. So Q2, how we will calculate? How we are calculating our median? So to find out the median, we will just take whole of the data set, and since this is having even number, right, it is having 8 data into it, so we will take 4th and 5th data, that is 5th and 6th data, that is 15 and 16. We'll divide it by 2, which we will get it as 15.5. Now we will calculate Q1, that is first quartile. First quartile it will be 0.25, second quartile will be 0.5, and third quartile will be 0.75, and fourth quartile, of course, it will be going to be 1. Correct? So how we will find this 0.25? You can just check out this process. I am not going to explain you, just read it throughout if you are interested. Otherwise I am moving to the by the operation of Q1. Once your Q1 is determined and then Q3 is determined, it is telling you that it is Q1 is something. Why we are doing Q1 and Q3 only? Because we need to find out IQR. This is a term which is a mathematical term which is getting find out by the difference of Q3 minus QR. So once you got this IQR, you will find out lower boundary of your whole of the data set. So lower of boundary, how we can calculate? We can calculate it by the formula Q1 minus 1.5 into IQR. And similarly, upper boundary we will be finding with this particular formula. So once your lower boundary and upper boundary is found, definitely you will be able to judge that what is your outlier into whole data set, correct? So for that, what we are doing is we are just using this particular formula into which DF values less than lower boundary or DF values greater than upper boundary. So whatever things are there in between, Whatever things are there in between are not going to be your outlier. Those are something which is to be there, but whatever outside of this, definitely those are outliers. So once you execute it, you will get to know that value you are getting is 100. So this 100 is only which we are, by seeing also we can say that this is going to be your outlier, correct? So by this method you can find out the outlier. Once your outlier is detected, now you can play around with that outlier. Either you can remove that outlier completely, or you can replace that outlier with some particular value, or you can transform that outlier with some whatever you are having formula or whatever you want to transform. Definitely you can transform that outlier. So removing that outlier, just you will use this particular one, where what we are doing is we are just taking all the values whatever is between lower boundary and upper boundary. So if we will take it, definitely the outlier whatever it is, it will be removed out. So that is what we are doing over here. Replacing outlier, we will just use dot clip method. What dot clip method will do? It will take the parameter lower, in which we will provide the lower boundary, and then upper, in which we will provide the upper boundary. It will take the data whatever in between, and rest of the data it will be clipped off. And how it will be clipped off? You can see that the outlier has been replaced with the value over here. We are having 10, 12, 14, 15, and after that we are having 100, correct? So after that you can see after 15 we are having 100. So now you can see that with dot clip method, this 100 is replaced by 25.375. Okay, so this is how we can replace our outlier. Now we are having transformation of the outlier. So how we are transforming it? We are using that outlier value. It means we are on the place of that outlier value, wherever outlier is there into your whole data set, we are just replacing that with the whole data set median. So whatever your median is, we are replacing it with that. So you can do multiple things with your outlier. Definitely you can either remove, either keep. What if you are keeping it, what logic should be applied, that definitely depend on your business logic as well. So these was all the concept regarding your transformation, and this was the last part of the transformation of in the pandas. So hope you found this video very knowledgeable and informative. If you found this video helpful, kindly like to the video and subscribe to the channel. It's my request, and see you in the next video with some other topic. Stay tuned to the channel. Till then, thanks again.